Earlier we said that all nodes store identical copies of the blockchain database, didn't we? And that's an issue that undoubtedly results in a lot of data storage and redundancy. However, this is the price we have to pay in order to obtain a truly decentralized peer-to-peer system without any middlemen. Moreover, data sets can be different in size. Some blocks may have 200 transactions, other blocks may have 500 transactions, still others may have 1,000 transactions. All these transactions also typically vary in the size of the information they contain in terms of kilobytes. The only capacity limit in the Bitcoin blockchain protocol is in the size of each block, which has been 1 megabyte since 2010. It was recently amended to effectively 1.4 megabytes with the latest upgrade of the Bitcoin software. But again, block sizes can vary up to that limit. You can check for yourselves what blocks look like on blockchain.info or other online block explorers. Here you can see some example blocks. Therefore, a blockchain can benefit from some standardization and rationalization of the data it stores. A mechanism that allows us to address this issue are cryptographic hash functions, which are an efficient way to secure data integrity and reduce file size. Hash functions are used to convert input data of any length into a compressed, unique, fixed-length string of characters, also known as a bit string. This output data serves as a unique reference code or digital fingerprint to verify the authenticity of some underlying data set without the need to actually check the entire data set. Here is a good example of what a hash function does in practice. Imagine you have files of different size, as shown in the image, a situation that frequently occurs in practice. As we said, different transactions have a different size in a given block. However, we want to be efficient and to be able to verify that these files belong to the blockchain through a fixed number of characters. Using a hash function, we can do that. See how the two files that are different sizes have a hash value that is of the same size? Good. The hash function we use is the same, but the hash value is different because the two inputs, the files, are different. Here's an example illustrating this even better. For the same input, the same sentence we have in this picture, and the same hash function, we obtain two totally different hash values because in the second sentence we have used a capital A instead of a small a. See? The two hash values are completely different. In practice, a hash function is a mathematical algorithm that maps data of arbitrary size to a bit string of a fixed size, also known as a hash. It is designed to be a one-way function, meaning a function that cannot be inverted and recalculated backwards to get the input data. The only way to recreate the input data, if one has the output only, is to attempt a brute force search of all possible inputs to see if they produce a match. A brute force search is basically systematically trying all possible combinations to find the solution. Hash functions are heavily used in the proof-of-work blockchain consensus algorithm. In our next lesson, we'll talk about digital signatures, a very important topic in the world of blockchain.